Okay, this is a continuation of lesson 7.3. Sorry about that last one, kind of abruptly stopped in the middle, but that's okay. It kind of makes sense to split this into two videos anyway. So the last video I ended right as I started to talk about this. I didn't know I was going to end it then, but I accidentally ended it. So we're going to start up right here with the PERT formula. So this is a growth formula, and this is the special one that's used in business and finance, which you want to think about it. And it's growth, so right, it's similar to our 1 plus r to the x, except this one is for a special situation, and you want to make sure you get this in your notes. And this one only applies when they specifically tell you that your interest is continuously compounded or compounded continuously. So whenever you see those magic words, compounded continuously, that's when you use, they just call it PERT because P-E-R-T. The formula is actually, you can think of it as a Y equals P-E to the RT, or sometimes it's written as A equals P-E to the RT. So A is your A or Y is your final or ending amount, and then P is your initial amount. And the reason P is used here is it comes from principal, P-R-I-N-C-I-P, I guess P-L, I think it's P-A, I'm not sure which principal they use, the P-A-L or the P-L-E, but principal is generally accepted as your amount that you initially have when you're saving money or money is growing. P-R-I-N-C, I think it's supposed to be an A. I don't know how to spell principal apparently. E is the E, the one we learned about up there, and R is your rate, and T is your time. So it's your initial amount times E to the exponent of rate times time. PERT, you'll just hear people refer to it as a PERT. And you have to have the continuous compounding happen. So if you look at our first example, boom, it says continuously compounding there. So when you're doing a test or a quiz, the way you know to not do your exponential growth, your initial amount 1 plus r to the t, the way you know not to use this one and to use this one are these magic words, continuously compounding. So, and continuously compounding means that your interest is calculated kind of instantly. I think we talked about it a little in class. Like you put $1 in, it earns interest, and so now it's worth, say, $1.01. So then right away you're earning interest on, instead of $1, you're earning interest on $1.01. So it's continuously updating the amount that you're earning interest on. So you earn money faster under continuously compounding. So suppose you deposit $700. That sounds like my initial amount. That's what I'm starting with. In an account paying 6%, that sounds like my R. Continuously compounding. Boom, I know I'm going to use this equation. What is the balance after 8 years? That sounds like my time. So remember, your final amount equals P times E to the RT, which in this case, they're asking for the final amount. What is my balance after 8 years? My P, my initial amount, is 700. E to the exponent of R, remember we always do the percent divided by 100, so that would be 0.06, not 6, times 8. And remember, if you're using your parentheses carefully, you can put that whole thing in your calculator. Let's try it here. Turn my calculator back on. So I have 700, use your E, you guys can't see that down here. E automatically jumps it up there for an exponent, and what I want to do is parenthesis 0.06 times 8, right parenthesis. And then look at your answer, make sure, does that make sense? $700, 8 years, $1,000. Yep, that's a realistic answer. Seems like it makes sense. So this is 1131.25 is what my calculator gave me. But remember, this is a word problem. Story problems require a story answer, which means at a minimum units, sometimes words. In this case, just our units, our dollars. So it's just an exponential growth problem, different formula because of the continuously compounding. And then this is saying how long will it take? So that tells me my time is my question mark for your account to reach 2,000. Well, we know it took 8 years to get to 1,100 here, roughly. They're asking how long to get to 2,000. So this is my final amount. And what my unknown will be is my t. So I should be able to fill in everything else. I'm still using that continuously compounding formula. Only this time I know the final amount. It's 2,000. The initial amount stays the same, starting with my 700. E stays the same. The rate stays the same. Time is what I'm solving for. So this is solving an equation. The variable is stuck up here as an exponent, like these ones we did up here. So my first step is isolate this E that has the variable attached to it. So what I want to do is divide both sides by this 700. So 2,000 divided by 700. 2.857, we'll say. You guys can't see that. There you go. So 2.857 equals E to the, I'm just going to write this as 0.6 T. Okay, so this, I could rewrite this as a natural log, but we're used to rewriting when our exponential's on the left. So I'm going to move the exponential over here to the left, and then I can use my arrows. So this is going to be natural log of 2.857, which is just a number I can put in my calculator, equals 0.06 t. There we go. We got our variable down here where we can solve for it. So I'm going to divide both sides by 0.06. So what I'm going to put in my calculator is natural log of 2.857 divided by 0.6, and that's going to give me my time. And then I'm going to see if it makes sense. Should be bigger than 8, right? More than 8 years. So what I want to put in the calculator is natural log of 2.857, right parenthesis, divided by 0.06. 17 and a half, we'll call it roughly. So the answer I get is 17.49, but we're talking years here, right? And this makes sense. 8 years to get to 1,300, 17 years to get to 2,000. I would say this is approximately 17.5 years. Because it's years, I can legitimately round to 1 decimal place there. Okay, do we have more? Yeah, we do. This is going to be, oh, this is a your turn. So you should try this and check your answer. I'm going to tell you what you should get for A is approximately 1708. $1,708. So this is the same idea. They give you the initial amount, the rate, yep, try this. And then in the second one, same idea, how long will it take? And this one you should get 10.87 years. And notice I gave these both approximately. That is it for 7-3.